friction is a force that, for example, if you've got a flower pot, I lost my green marker. I'm pretty sure this is the illustration in your book. That's why I'm doing the flower pot. Okay, you've got a flower pot with a flower in it. Not that that matters. The flower pot has mass. Pretend this is level. If I just push this flower pot with my finger very gently, is it going to move?
Probably not.
Probably not. Okay. Now, there is force being exerted on this flower pot, right? And forces are what cause something to move, or a mass to move. So I'm putting a little bit of an unbalanced force on this, you would think, right? Because you can't see anything else pushing on it. Okay. The force down here between the surface that the flower pot is sitting on and the flower pot itself is friction. And friction, so as I'm pushing here gently, so that's a little arrow for a little force, friction is pushing back and resisting the motion of the flower pot. Okay? So how do I move the flower pot?
Apply more force than there is friction.
Very good. So this is a balanced force. I need to make the force unbalanced. So my force needs to be big. Okay? That's how friction works. Okay. Now, okay. So it opposes the motion of objects that touch as they move past one another. There are two kinds. There's static friction that acts on objects that aren't moving. So that initial little push that I gave the flower pot, the opposing force was static friction, okay, because it wasn't in motion yet. But now, if I push it with a bigger force and it does start moving, there's still some effort required, right? I don't just get it started and then it's infinitely easy to move, right? That opposing force, once it's in motion, is sliding friction. Okay, so there's a difference. Have you ever been trying to push like a cart, a heavy cart or something, and have you noticed that that initial push to get it going requires more effort than keeping it going once it's already going? That's because static friction is has a different value than the sliding friction. Static friction is usually a lot harder or a lot more force than the sliding friction. So in this case, remember I had balanced forces because I had my little arrow of static friction and my little arrow of push, right? To overcome the static friction, I needed my force to be greater than this, right? But then once it's in motion, the static friction might only be, the sliding friction might only be half of what the static friction was. So I don't really need nearly as much force to keep it moving. Good? Okay, that's the difference between static and sliding friction. This is also really, really important in earth science